What happens when a piece of wood burns? What exactly is fire? Everyone has had this experience. You set a piece of wood on fire and end up with light, heat, and eventually a handful of ash. From a solid piece of wood, you are left with a small pile of ash. So where did the wood go? What happened to all the initial matter? What is fire made of? And what is ash composed of? In short, burning wood leads to the invisible release of gases, mainly carbon dioxide and water vapor, though there are around 100 different gases released. Ash consists of some remaining carbon compounds. Here's what happens in detail. Wood is composed of the following, depending on whether it's hard or softwood. Cellulose, 40 or 50%. Lignin, 20 to 30%. Hemicellulose, 15 to 25%. Water and other organic substances, polysaccharides, pentasands, hexosands, resins, tannins, dyes, waxes, alkaloids. But at a fundamental level, like all matter, wood is made up of atoms. Approximately, the atomic composition of wood is 50% carbon atoms, 6% hydrogen atoms, and 44% oxygen atoms. Simple, right? Since we've mentioned carbon, it's important to note that carbon is the most crucial atom for life. This relates to the structure of the carbon atom. Carbon has 4 electrons in its outermost shell, which engage in reactions by sharing electrons with other atoms. Carbon's ability to form 4 bonds, thanks to these 4 electrons, makes it essential for building complex, large molecules. Only 4 types of atoms, oxygen, carbon, hydrogen, and nitrogen, make up 96% of the human body. There are 92 naturally occurring elements, but only 25 are needed to form a complete human being. Plants, for instance, need just 17 types of atoms. When wood burns completely, half of its mass transforms into carbon dioxide and the other half into water. Burning is accompanied by the release of energy. After all, that's why wood is used to heat homes, right? The energy released is between 20 and 21 megajoules per kilogram of wood, depending on the type. Surprisingly, this energy is actually the energy received from the sun during the tree's growth. So burning wood is almost literally the release of stored solar energy. When wood burning reaches temperatures above 260 degrees Celsius, it enters the pyrolysis phase, a chemical reaction that tends to sustain itself. Pyrolysis is the process of thermal decomposition of organic compounds in high temperatures and without air. Up to 85% of the wood's mass and 60% of the heat are contained in the gases produced by pyrolysis. Smoke and creosote, a condensed part of the smoke appearing as a dark yellowish oily liquid, represent the unburned portion of wood. Smoke contains around 100 chemical compounds. Wood burning occurs in 2 stages. 1. Primary combustion, the burning of the solid part of the wood. 2. Secondary combustion, the burning of the gases, which actually produces the fire's visible flames. As mentioned earlier, complete combustion of wood produces only carbon dioxide and water, without visible smoke or creosote, and without harmful emissions. However, complete combustion is hard to achieve, requiring specific conditions. The burning temperature must be between 600 degrees Celsius and 800 degrees Celsius. Extra oxygen is needed to stimulate burning, and there must be enough time for the combustion reactions to fully complete. If you use wood for heating, it's important to know that the drier the wood, the more efficient the burning, and the fewer harmful emissions.